Hello guys, in this tutorial we are going to talk about how to derive spatial and temporal statistics using a bunch of raster data that we have. You can say that this tutorial is almost an extension to the previous tutorial which I did explaining how to obtain the zonal statistics corresponding to a certain raster using a defined polygon area. Now I'm going to use the same dataset, but over here we are going to expand into multiple rasters instead of working on just one raster. Now, if you can recall, we have been using a dataset which was actually covering the boundaries of the country Portugal. Now, as you can see over here, the source of this data is actually from Chirp's gridded satellite rainfall data. So, in this example, I'm showing you one of the rasters which corresponds to the 15th of April 2020. And the spatial distribution basically shows you how the rainfall was distributed on that particular day. And I have another shapefile which shows the districts of Portugal. Now in this tutorial, what I'm going to do is I'm going to pick two districts out of all the districts. Let's say I'm going to pick one district from the north and one district from the south. Let's say we pick Porto and Faro. And I'm going to calculate the average rainfall based on the boundary of these two districts. Let's say for Porto, I'm going to calculate the average rainfall using the zonal statistics of this raster. That means basically we are going to get the pixel average of all the pixel values within the boundaries of this Porto district as well as the Faro district, and we are going to do a simple plot like this, and we are going to represent the daily averages in a plot like this. Now over here you see two plots. On the top you see the average rainfall in Porto district on April 2020, and on the bottom you see the average rainfall in Faro district on April 2020. And from the values you can see actually the amount of rainfall which Porto district has received is quite significantly higher than the rainfall which was recorded in Faro district according to this gridded satellite Chirp's gridded satellite rainfall data. So in this tutorial we are going to basically discuss how we can obtain this kind of a temporal variation of rainfall. You can basically apply the concepts to any kind of a raster that you would like to work with. So let's go ahead to the tutorial and see how we can generate this kind of plots using the concepts of zonal and temporal statistics. Alright, again I would like to actually give you a bit of a overview of the data that we are going to work with over here. You can see that I have one shapefile which corresponds to the districts of Portugal, and on the other hand I also have the rainfall dataset, which is basically a bunch of rasters, 30 rasters, which corresponds to the recorded rainfall values from 1st of April up to 30th of April. The data source is, as I mentioned, it's Chirp's gridded satellite rainfall. Alright, so let's go ahead and create our Python script to get started. You can right click over here, and I'm going to name this as analyzing spatial temporal rainfall data.py. Alright, first we can get started by importing all the libraries that we require for this tutorial. Let me go ahead and import all the libraries that I'm going to work in, and when it comes to the time actually where I'm going to be using these libraries, I'll explain how we are going to actually make use of these libraries. But for the time being, let's go ahead and import all the libraries that we are going to use. So we will have the GeoPandas library, the raster.io library, raster stats library, matplotlib for all our plottings, and pandas, OS, and finally the numpy library as well. Alright, so the first thing that I'm going to do is I'm going to read in the shapefile which we have over here into GeoPandas GeoDataFrame. How do we do that? Let me go ahead and create a variable called districts, and that's going to be equal to gpd.readFile. And over here what we do is we specify the path to the file, right, districts.shape, and after that you can go ahead and save. Alright, now you can go ahead and run this, and you can do a quick plot. In case if you would like to have a look at the data, you can see that we have the shapefile which contains the districts over here, and if you would like to look into the data as well, you can just say districts and it'll print the information out for you. Yeah, so Now if you can notice, you can see that all the different districts are sort of embedded in one shapefile, but for my task I would like to sort of isolate the two districts which I'm interested in, Porto and also the Faro district over here. So there are actually multiple ways of sort of extracting single polygon elements from a shapefile. I'm going to extract the particular row which I need. For example, let's say I'll get started with Porto. So if I say districts and if I specify the location, now if I put iloc, I have to put the index, but if I put the location, I actually just can specify the index directly by the number. For example, if I specify 12 over here, you can see that now if you extract only this row, it actually gets transformed from being a GeoPandas geodata frame into a Pandas series. That means this particular extraction now does not carry its geometrical properties, even though it has this geometry column. Right now, Python recognizes that as a Pandas series. So we have to transform this into a GeoPandas geodata frame again. And that's not that difficult. And as I discussed before, you can see now the order has been flipped a bit. Before over here, this was the column heading, the name one, and Porto was under that. And now you can see the whole structure has been sort of flipped. So if you want to turn this back to this format, what you can do is you can actually get the transpose of this. Now before doing the transpose, I'm going to first convert this into a Pandas data frame. So let's say that I will create a Pandas data frame called, let's say, Porto df, which is going to be equal to pd.dataframe. And that data frame is going to be equal to basically whatever we typed over here. All right, now if I go ahead and run this, well, I'll get rid of this plotting command over here because we don't need to plot each time when we run the script. Yeah, now if I say Porto df, you can see that now we have a Pandas data frame. If I check the type of Porto df, it'll tell me that now it's a Pandas data frame, which has some attributes inside. But as I told you, I would like to now flip these two into the format that we saw over here. So you can do that simply by taking the transpose of this. So if I say dot transpose, and if I run this, and now if I say Porto df, you now see that this geometry has actually become one of the column headings over here, and then all this geometrical information are under this particular column heading. So I like to have it in this format. If I go to the variables explorer, you can see that now over here we have two columns, the name of the district and also this special geometry column. Even now this is still not a GeoPandas geodata frame. As you remember over here, when I check the type, it's still a Pandas data frame, but converting a Pandas data frame into a GeoPandas geodata frame, especially when you have these geometrical properties, is actually not that hard. What you can do is you can create another variable called, let's say, Porto polygon, which is going to be equal to gpd.geodata frame, because now we are going to create a new geodata frame based on this Pandas data frame. But additionally, you have to specify the geometry column. And in this case, it happens to be this geometry column. So I'm going to specify that over here. And now if I run this script, and if I say polygon, now you see that there were some slight changes in this geometry column. And what you can do is you can have a quick look at the type of this Porto polygon. And now you can say that it's a GeoPandas geodata frame, which means you can directly plot this and get the boundary of the geodata frame as well. So you can do something like Porto polygon.plot, which will basically give you the boundaries of the district of Porto. Now if I quickly open back the QGIS, and you can see that we basically managed to extract the boundaries of this particular district now into one single GeoPandas GeoDataFrame called Porto Polygon. So I'm going to do the same thing with the second district which I'm going to be working with, which is the Faro district. So I can copy this one and maybe do a couple of changes. Alright, now if I open the original district's shapefile, or in this case the original district's GeoPandas GeoDataFrame, you can see that the index value corresponding to Porto was 12, but in the case of Faro it's actually going to be 7. So I'm going to change this location to be 7, but the rest, yeah, this one needs to be changed to Faro DF as well. Yeah, I guess the rest can remain as it is. And now if I say Porto Polygon dot plot, it'll give me a plot of the Porto district. And similarly, if I say Faro Polygon dot plot, it's actually going to give me a plot of the Faro district, which is one of these districts in the southern area of Portugal. This one. Alright, so that's out of the way, but we still have to do a bit of a specification of the coordinate reference system, because by default now this doesn't have its own coordinate reference system. And if I check the coordinate reference system of districts .crs, you can see that it's in WGS 1984, which corresponds to this EPSG 4326 coordinate reference system. I'm going to assign the same coordinate system to these two GeoPandas GeoData frames as well. The way to assign a coordinate reference system would be just you specify the name and say CRS, and I'm going to assign the same CRS as districts. So what I can do is I can simply copy this and paste it over here, and similarly I can assign that to Faro Polygon as well. Alright, now if I run this and if I say Faro Polygon.crs, it's actually returning us the coordinate reference system information, which is in this case, which happens to be the WGS 1984. Alright, now let me go ahead and comment this out so that it'll be clear for you guys. So the next thing that I would do is I would create one empty Pandas data frame to which I can fill in the information which I'm going to extract later from the different rasters. So let me go ahead and comment that out as well. And I'm going to call that as, let's say, data. Keep it simple. And that's going to be equal to pd.data frame. Again, this is actually the way to create a new Pandas data frame. If you don't want to fill anything at the moment, you can actually just pass an empty string like this. And among the columns, I would like to actually have, well, not among the columns, the exact columns that I would like to have are, well, I would like to have a column for date, and I would like to have a column for, let's say, average rainfall in Porto, and similarly I would like to have another column for the average rainfall in Faro. Alright, and then I would like to specify the index. Now the index values can actually start from 0, but if you really want to get the index value to start from 1, actually that's also possible. You can simply use np.arrange, which is coming from NumPy library which you imported before. For example, if you say np.arrange 0, 10, you can see that it's actually creating us an array starting from 0 up to 9. But in this case, I would like to create indexes for each rainfall each day. If I open this file explorer and if I open the rainfall data, you can see that I have days starting from 1st of April up to 30th of April. So for each and every day, I would like to actually create an empty row, which we can specify using this index. So I'm going to create indexes starting from 1 up to, let's say, 31. Now what happens then? If I say 1 and 31 over here. It's actually giving me an array starting from 1 to 30, which is basically what I need. Right, now I can go ahead and run this and maybe have a quick look at the data pandas data frame. You can see now it's an empty pandas data frame. We don't have anything over here, which is basically ready to receive the information once we get to that point. Now I would like to come to the point where we actually start reading in different rasters. Now I'm going to do that using a for loop. Now let me go ahead and comment this one. Rainfall rasters. So we're not only going to read in the data over here, but we're also going to do the spatial statistics, the zonal statistics calculations during each iteration as well. So that's what's going to be rather unique in this tutorial compared to the one that we did before. Alright, so we can do that simply by using a for loop. I can say for, I'm going to create a variable called, let's say, rast in. Now I have to specify the folder in which we are going to actually look for each of these rasters, and that's going to be inside this folder, isn't it? So I'm going to say os.list dir, which is going to basically list everything inside that particular folder, which I'm going to specify over here, and it's going to assign during each iteration the values that it sees into this rast variable which we specified. For example, if I now say print rast, and if I run this, you can see that it's actually printing out all the names that it sees inside that particular folder, as you can see over here. But we actually don't need to print them out necessarily, but instead what we need to do is, now in case if there happens to be files of other formats, this is actually going to read them as well. But so in order to avoid that, I'm going to put another condition saying that if the last 4 digits, the last 4 values of the rast string, this is the way to specify that, is equal to this file format, which is the .tiff. Only then we will proceed with the rest of our calculations that we are going to do. So that takes care of the issue of the potential issue of having different types of different files with different file formats, because inside this loop only the files which with the extension .tiff will get read, but the others will be ignored. Alright, so during each iteration what I'm going to do is I'm going to first read in the raster. I'm going to specify that as a RF because each of these rasters are actually rainfall rasters. And to read in the rasters, now we can use the raster IO library which we imported right over here. So we can say raster IO.open, and we need to specify, yeah, it's going to be the same file path over here. But during each iteration I would actually like to assign the name which is going to get recorded in this rast variable into this file path. Now how can you do that? You can specify a double slashes over here and just say plus rast. Now if I try to actually see how this whole thing looks, yeah, it actually looks like the proper assigning of the path that we would normally do, but the difference is that during each iteration this part will change because it'll start from this 1st of April and then it'll go to the 10th of April. Somehow it's not sorted, but that's not going to matter much because we will do the sorting later. So during each iteration only this part will change, and it'll actually record the rasters according to this order and do the calculations that we are going to assign for it to do for us. Alright, and then I'm going to convert this throw this information into a NumPy array. You can say that rainfall array, which is going to be equal to this raster that you read dot read, and similarly I'm also going to specify the affine. Now I explained in the previous tutorial what this affine basically means, so if you really need to understand how to perform these spatial statistical calculations in detail, I would recommend you to actually go back to the part 1 of this tutorial and first check it out, because I spend quite amount of good time in there explaining each and every line of code So I'm just going to assign this to be rf.transform. Alright, now if I run this, what's happening is that during each iteration, it's actually jumping over from one raster to the other. It's basically reading each and every raster, but right now, the information which gets recorded in this rainfall array and this affine are corresponding to this final raster which it read. We can also have a quick look at the variables explorer, and if I check rainfall array, now you can see that this -9999 is actually the missing data, but somewhere over here we start seeing the actual rainfall data which corresponds to the final raster that it read. Alright, now I'm going to go ahead and calculate the spatial statistics. First, let's do the calculations for Porto. So the spatial statistic that I'm going to calculate is basically the average rainfall of Porto. That's going to be equal to raster stats, which we imported from here. And we are going to use zonal stats. And we have to specify a couple of arguments over here. So the first one that we need to specify is actually the polygon boundary, which is going to cover the area of the raster, for which we are going to extract the average values from the raster. So that's basically given by this Porto polygon over here. That's the polygon. And as the second argument, we also need to specify the numpy array that we extracted corresponding to that polygon. And third, we need to specify the affine. That's going to be equal to this affine over here. And next we specify what sort of statistics that we need to extract. You can either extract the maximum value, minimum value, a whole series of statistical values, but in this case we are going to limit ourselves only to the mean, the average value. Also we need to specify this argument GeoJSON out to be true. Alright, now if I run this and if I go to this variable average rainfall of Porto, you can see one element which is a dictionary, and that corresponds to a mean value of 2.536 and so on. And that actually corresponds to the raster of this particular date. This is 9th of April. Just keep in mind that these rasters are not read in increasing order, so right now it's just mixed up, but don't worry about that much. So since this is a dictionary, you can actually extract the values directly from here. You can see again that this dictionary is embedded inside a list. So first we will have to go to this section by passing through the list, and once you are inside the list, you can actually call for the value which belongs to this key, which happens to be the mean. Alright, so the way to do that would be quite easy. Now if I say average rainfall Porto, you can see the type is a list. So what I'm going to do is I'm going to select the first element of the list, which happens to be the index number 0. And inside that index number 0, I'm going to specify the key, which is, if you can recall again, mean. So this simply gave us the mean value which corresponds to that final raster, which corresponds to the 9th of April. So since I can extract this value now, I'm going to basically assign it to the same value, because this is actually the average rainfall value of Porto for that particular day. Now similarly, I can do the same thing for Faro as well, for the Faro district. And what differs is the name that we assign over here, and in this case it's going to be Faro polygon, and over here it's going to be the average rainfall of Faro. Alright, so if we go ahead and run this, now you can see that it's going to take a bit of time, because now it's extracting the information from each and every raster, just that it's not recording it to anywhere other than just recording it to these two variables, which are the average rainfall of Porto and Faro. Now if I go ahead and open over here, you can see that on this particular day, both the districts have received on average a rainfall value of about 2.5, but it might be different when it comes to the other days as well, but that's going to be investigated later on. Alright, I guess now it's a good time to actually start filling in this data Pandas DataFrame, because as you can see from here, we have this average rainfall of Porto, average rainfall of Faro, just that we don't have it for each day, but we can actually program it to record during each iteration. Don't just iterate over the rasters and do nothing, but iterate over the rasters and extract the values and then just put it into this Pandas DataFrame. And that can be done quite easily. Now if I open this data Pandas DataFrame, you can see that we have 3 columns, but we don't have any values. And if I recall the way to select elements, select row specially corresponding to a certain index number. Let's say if I say index number 1, it's actually going to return us all the values over here. So these are the headings of the columns, even though it appears as rows. So if I want to select the row number 2 of the Pandas DataFrame, you can see that we can actually select elements like this. And not only that, you can actually assign values in this way as well. Let's say if you want to assign a value to the date, which is on the row with the index number 2. Let's say you want to specify some arbitrary value 5555, and if I say press enter, and now if I go back to the variables explorer and check, you can see that in this index number 2, this value has now been assigned to this date. So in this manner, what we can do is during each iteration, we can actually assign values to this Pandas DataFrame. Now I don't have to clean this up, because I can replace this actually by the real actual date, which we can extract from here, from the script. So what I'm going to do is I'm going to say data.location, but now over here we have a problem, because during each iteration I would like this index value to increase, because when we start, I want the index value to have 1, and then in the second iteration I would like the index value to have the value 2, so that it actually be directed into the correct row of the Pandas DataFrame. Now an easy way of doing this would be specifying an increasing variable. So let's say I have a variable called I, and if I say that when it goes to the next iteration, make the value of I equal to something that's higher than 1 unit of what it was before. I guess you get the idea. If I assign the value of I to be 0 over here, it jumps into the loop having the value of I to be 0, and during this iteration it's actually going to put the value of 0 over here, and when it comes to this row it's actually going to increase the value of I by 1 unit. Sorry, in this case I would like to actually have the value of I to be 1, because my index is starting from 1, as you can see over here. Alright, so in that case the value of I is actually going to be 1 over here, and when it reaches this row the value of I is going to get increased by 1 unit, which happens to be 2, and during the next iteration the value of I which gets recorded over here is 2, and after it reaches here it becomes 3, and so on. So that's basically what we need to do, isn't it? So I can say that the value of this date is basically going to be this rast variable, but we have some issue if we only use the rast. As you can see, it actually comes with this .tif part as well, which we do not really need. So the way to get rid of that would be simply specifying the part of the string that we need to have. We exclude the final 4 digits, the final 4 entries, elements, and we get the date over here. So we can specify this to be the value over here, and similarly we have 2 more columns to fill. So this part now I think you can imagine is going to be the same except for the column name, which I have forgotten now, so I have to check from here. It's average RF Porto, and over here average RF Faro. Average RF Porto equal to something, and over here it's going to be average RF Faro. And now I guess you can imagine that these 2 values are going to be equal to just what we record over here and what we record over here, in fact. Alright, now if you run this, you will see that it's actually taking a bit of time because it's reading each and every raster, recording the values, doing all the processes for us. And now if I go to this data, you can now see that it actually recorded all the values corresponding to the average rainfall of Porto and Faro into 2 different columns, along with its corresponding date. So that's pretty cool, isn't it? Now I guess about 90% of the work that we need to do is done at this stage, but we are going to do some minor arrangements. For example, I would like to sort this according to the increasing order, and then maybe do a simple plot so that we can visually see how the rainfall distribution occurs, the average rainfall distribution occurs for each district during the month of April in year 2020. Alright. Now something that I'm going to do is I'm actually going to convert this into a date time format so that I can sort the values in an increasing order, because right now it's just a string, as you can see. And just keep in mind that now we are out of the for loop that we were working on over here. And I would say data, and I select the column date, and that's going to be equal to pd.toDate time. And again, I have to specify the particular column over here. And I can either specify the time format, the date time format, or sorry, this needs to be data, or I can pass an argument saying that infer date time format equals to true, in which case Pandas is actually going to be smart enough to figure out the format by itself, and it's going to convert this into a date time format. Now we can have a look how that is going to work out for us. If I open the data over here, you can see that now it actually has been converted into a proper date time format. Well, I don't need these minutes, the hours, minutes and seconds part, so I can just simply get rid of that by saying data date. It's going to be equal to, again, data date dt and date. And now if we check our Pandas DataFrame data, you can see that now it's left with only the entries of date, but without the hours, minutes or seconds. Alright, now it's a good time to actually go ahead and sort this. So the way to sort that would be, you can say data equals data.sort values, and we can assign by which column we need to sort the values. And as you can guess, we are going to sort the values by the date column, isn't it? So let's go ahead and run this and this one as well. And now if you check, you can see that the values have already been sorted. Now it's just a matter of creating a couple of plots to visualize this data. That's going to be quite easy. Over here we can say creating the plots. Alright, over here, since I'm going to create 2 plots, I'm going to make some space which is going to be enough for 2 plots. So I would say figure axis 1 and axis 2, which is going to be equal to plt.subplots. This plt is coming from the library that we imported over here, matplotlib.pyplot. And as I've explained to you guys before, just think of this line as you creating the canvas for you to actually plot your stuff in, because this line itself doesn't plot anything. It's just making you the empty spaces, sort of arranging the spaces for you to put your real plots into. So the subplots I'm going to assign over here 2 and 1, because we are going to create these plots one after another, sort of stack them on top of each other. And yeah, let me determine the figure size later. And now what I'm going to do is I'm going to simply plot this data.plot, and I can ask the program to assign the x coordinates to be the date, sorry, the x-axis to be date, and the y-axis is going to be average rainfall of Porto, let's say. And we can pass an argument called kind, which basically gives the indication what sort of a graph it's going to be. It can either be a line graph or a bar chart. And now we are going to throw this plot into this AX1 axis, and along with that we can also specify one title. We can say average rainfall in Porto during April 2020, and we're going to display the values in millimeters. Alright, and similarly what we can do is we can just copy this and paste it over here, but just we are going to change the y-axis over here is going to be faro, and the axis that I'm going to throw this into is axis 2. Alright, I'm sure this plot is going to look hideous at the beginning because we did not assign the spacings properly, but we can just do all those kind of minor amendments later. We can just go ahead and run this. Yeah, as you can see now, the plots have been stacked on top of each other, but there are many things that I actually have to change in here. You can see that on top we can see the average rainfall in Porto during April 2020, and over here I think I'm supposed to change this to faro. And something that I can do is I can actually make some space for these plots. For example, if I assign the figure size to be something like 10 by 8, and if I run this, I think it's going to look a bit better. Yeah, but you can see that still some values actually overlapping on top of each other. Now, one easy way to sort of get rid of this is by passing an argument called plt.TightLayout. And that's going to basically automatically adjust the spacings in a way how matplotlib thinks it would be actually good. But we can just have a look at that and see whether it suits our purpose or not. But if not, we can actually manually assign the spacings as well, which is not that hard. You can see that now the plot looks much better. In case if you need to sort of keep some more space in between these two plots, you can basically get rid of this auto tight layout, and you can pass the argument called plt.subplots adjust. It's that easy. As you can see over here, we can specify the left spacing, bottom spacing, right, top, width space and height space. I'm only going to specify the height space, which is S space, H space. And I'm going to maybe put a value like 0.8, and let's see how that one looks. Yeah, I think now it's much better. Now as you can see over here, it shows you the average rainfall distribution in these two districts. As you can see from the figures, the values over here are actually quite high. The rainfall which Porto has received, the maximum is going to almost about 60 over here, but over here you can see that the maximum is about 12. From this average rainfall distribution throughout the month of April, you can get the general idea that maybe the rainfall in Porto might be a bit extreme. The rainfall that Porto receives might be a bit extreme compared to the rainfall which Faro receives, which is actually more down in the south. Even you can quickly have a look at the data itself. If you say data, you can see actually the distribution of the actual data. And if you say data dot average rainfall Porto, it returns you that column. And if you say maybe the sum, yeah, it's showing you the total sum during the month of April 2020 of Porto was on average 165 millimeters. But when it comes to, let's say, Faro, the total sum is about 55. Even though it had many days of rain, the values are actually quite small. But over here, when it receives the rain, we can sort of justify that the amount of rainfall that it receives is actually quite intensive, even though the number of rainy days are actually on average quite low compared to Faro. So I guess that's our interpretation of this rainfall data for this exercise. I guess you did learn something new, and if you did, show your support by hitting the like button, and you can even consider subscribing to our channel if you would like to see tutorials like this in the upcoming days. So thanks a lot for watching, guys. If you do have any questions, comment them down below, and I'll get back to you guys as soon as possible. So until the next tutorial, take care, guys.